So did I track the conversation that it was tied to the graphics card? Did you say?
Yeah, these will be fixed for your particular graphics card and maybe your driver, but
So
they'll
so really, then when we're talking about specifically Android devices, I guess is what my mind jumps to, because you never know what the manufacturer is going to do. So I think that this would become a real big issue in the Android land.
I've been shopping around for a better Android device, and it's never spelled out exactly whether they have this, and I don't really want the device for all this fanciness. I just want it to test on it. So
I'm pretty sure the one I suggested has that. But
yeah, I think so. So we'll
I'm
see.
going to say that being the very latest generation from them probably has it. I suggested he get the Nexus 10 if he wanted something powerful in the Android market.
But how would you do that if you wanted to compensate for least common denominator then? I mean, what are we really... You either have to pick a device and say this is what it's supported for, right? And then be very specific about that. What's that?
I might have the least common denominators. I got them. They were Google giveaways for developers at events.
What do you have? What are you working off of?
I'm using a Zoom, so it's fairly old at this point. It doesn't have high precision.
And what you're wanting to do runs on it?
Yeah, I actually maybe I should get into this point too. That I brought up that you only have 4 inputs to your shaders, right? And that's actually an artificial limit because there is another way, but Corona hasn't documented it yet. So if you go through a different channel, and they said they wanted to clean it up, so they haven't exposed it yet. This is the uniform user data, and that you can get up to 64 inputs, I guess, but they can't do certain optimizations. So right now, what we have available is 4, or if you can sneak it through a texture, there's that, but that's more difficult. But often for one of these inputs, you won't need the full range for one input, so you can possibly squeeze 2 of them together, right? This would be like in an integer, you could take half of it for one integer, half of it for the other. If you had a 32-bit integer, 16 bits for one, 16 for another. And what I've been doing is squeezing. Well, the application I've been using it for is a number between 0 and 1. You can squeeze 2 of those together if they could be scaled to integers between 0 and 1023.
So let me make sure I'm tracking the conversation correctly. So you're saying that left by itself, one I don't even know what the term is, but one object might scale to the point where the math gets sideways, let's just say. But if you know that you can break that up into 2 or more items, then you can mitigate some of the exponential growth, the floating point issues or whatever, and then you can just work with those multiple objects to create the same effect, but know that under the hood you're working with multiple objects as opposed to just one object.
Oh well,
is that sort of like what you're saying?
Nope. I was actually bringing in another point that would dovetail with what I.
Okay.
So the problem I'm talking about is that we only have 4 inputs to a shader, and that's not always enough. So I think if you didn't need the color, you could probably sneak things in through the color, but I haven't experimented with that yet. but if you need more of this, and you can make the data fit this style of fit these ranges, maybe you can squeeze them in. And before what I had was where I had the integer part represented one value. So if I had x and y together, the x would be in the integer, and then the floating point part would be y. But because of this problem, when I got up into the high numbers, I lost most of y. When I got way up there, it was only 0.5 between the numbers, which was nothing like what I gave it to begin with, right? It's getting rounded to these power of 2 boundaries. So what I ended up doing was, because I've been reading up and reminding myself on all this floating point stuff, is to use the knowledge of how it's implemented and hack the number that way. And I actually need some testing of this on some other devices. I've only tested it on Android and Windows, and I had to do some special stuff on Android because.
So have you yet to test it on a high precision case or a?
I need to test it on. Well, I need to test it on everything Apple, iOS, and Apple itself, and.
Well, feel free to send me a
high precision Android.
Send me a copy. I've got a iPad, the third one, so yeah, I believe it's the AX8 or whatever it is. I can't remember the name for the processor or whatever.
Yeah, and then I have the original. I have the original iPad, and I also have a iPad Mini first gen. So
okay,
so we could.
Yeah, we're on board helping.
Yeah.
All right. So
yeah, of course. So we got to go through the whole process for the thing. Do you want us to send you our UDIDs?
Oh, I'll figure that out.
Figure it out later. Okay, not for the show. Sorry.
This is the magic anyway. This is doing all of that stuff I've mentioned, and I'll show you one that is my. I think this is currently my my shader that requires the most input. It requires 7 inputs, so it's an ice effect. Is that visible?
Yeah, we see it now.
Okay.
The angel looks like it's turned into an ice sculpture.
So it's got 3. This is how much the ice bends light data. This is the brightness of this light that's around here. And the light position is 2 inputs, and it's an X and Y. So those I needed to pack together because I was running. I have 7 things here, so these 3 and 2 values for each point. And the eye is where this background texture is looking. And so that's 6, or that's 5, I guess. And then these 2 have to be packed together too. So they all fit into 4 inputs at that point. And did something very non-ice-like or something in that range. But this is the brightness.
So what you've done is you've taken those 4 inputs that you were talking about earlier, and you've done what to them in order to make this
so the light and the position are all just 0 positions between 0 and 1. So left is 0, right is 1, and ditto for up and down. So I packed those 2 together into a number because I knew that I could scale these ranges to 1024, and it would be fine for me. For a larger screen, I think you'd have to make a new packing scheme. But I haven't done that, and I don't have anything really to run through its paces. But these numbers, they're within 2 to the 20, so 2 to the 10 times 2 to the 10, which is 1024 times 1024. It's a little over 1 million. I can cram those into the floating point representation, and they seem to work out. But barring failures I discover on these tests. So this is a way of, rather than going through the naive scheme I did before where I was just passing it through the fraction. And what would happen would be if I had something way over on this side, so all the way over here, the integer part would be very big, very large, and then the Y part would just disappear, so it would snap to the top or the bottom, the light or the eye position.